All right. Good morning, everyone. This is Jeff Scott. Today is Monday, the 24th of July, day 37 of our AWD1100 C# programming class for the summer session at Rankin Technical College. I want to start by going over this email that I sent out to you on Friday of last week. All right. So I have graded everything that has been submitted to me AM Thursday of last week. The grade book on Inside Rankin has been updated. All right. Now, if you look through there and you think I've missed some kind of an assignment, if you're like, I turned this in, you didn't grade it, you gave me a 0, just let me know. That's totally fine. All right. A couple of you have gotten behind on your assignments. 2 of you still have not taken the chapters 12 through 16 test. All right. Now, as I say here, I earlier said in the semester that I would give partial credit for work that's turned in late, and I will do that. But if you are behind, we are done 3 weeks from this Thursday is our last day. So you've got to step it up, as I've said right there. Today, we're going to go through chapter 19, which is an introduction to database programming. The video that I'm doing right now, of course, will be public. When I get done, I'm going to be doing a private video. All right. And I'm going to go over the chapters 12 through 16 test that you were supposed to do last week. Now, at 8 a.m. tomorrow morning, I will be sending each of you in this class an invite to that video. What that means is, once I send that out to everybody, if you have not taken Hot 6, all right, and I've already sent out to everybody the video on the key or whatever you want to call it, then you get a 0. I cannot change that. That's not fair for the people who did it and turned it in on time. So if you have not yet taken the Hot 6 test, you still can do so and turn it in. You will not get full credit, even though if it's 100% correct, but you will get partial credit, which is better than no credit. All right. So that was the first thing. Going over what we, our email for this morning, I realized I sent you the same thing twice, so sorry about that. And I resent the other one I meant to send. So again, today is day 37. We're going to start going over chapter 19. In fact, we'll go through all of chapter 19 today, which is an introduction to database programming. In addition, the first 2 things that you see on there are Word articles that I sent out to you. We'll take a look at them in a little bit. 50 database terminologies that every developer should know, and database and SQL roadmap. Everything you need to know about SQL. All right. So we'll go over those. I also sent you a couple of PDF cheat sheets, one for MySQL, which is one database system, another for SQL Server, which is another database system. All right. Then next, I sent you out a couple, the last 3 things on there are things we're going to be using more next week. All right, there's something that says Acme DB for database, schema and records.txt, Acme widget DB queries.txt, and a zip folder with some stuff for it. And actually, all right, we will look at most of this stuff in here this week. In addition, and I'm not going to click on one of these, I sent you links to some tutorials. A MySQL tutorial from W3 Schools, an SQL tutorial from W3 Schools, an SQL keyword reference from W3 Schools, and about a half an hour long video on how to install SQL Server and SQL Management Studio. Okay. Tomorrow, as it says, we're going to go over additional database examples. I'm hoping by Wednesday we will do a program together. Don't worry about it right now. All right, Thursday will be our lab day. Now, as far as that goes, please make sure that you are working on the following. All right. Oh, remember that portfolio is due 3 weeks from Wednesday. So this Wednesday is the 26th. So 3 weeks from Wednesday is August 16th. And on that, by that date, you have to turn in your electronic portfolio. I sent you this earlier. As always, if you lose something or if you say, hey, I never got that, send me an email and I'll send it out again. I have no problem with that. I did an earlier video today where I showed you an example of using Mobirise. All right, you don't have to use that, but you can. On that same video, I also showed you how you can publish your portfolio to GitHub pages. You have to do this. This is 1.5 tests worth of stuff. All right, so that's the first thing. Secondly, you should also be working in here on your final project. All right. That was to create a C# bookstore app. So hopefully you have started on this. And even if you say, well, geez, I don't know how to do all this, do what you can do for now. All right. So that's the other thing. So on Thursdays, you should be working on any written tests that you've got to, any labs you've got to, any homeworks you've got to, then the final project and the electronic portfolio. By this Wednesday, all right, the stuff we did for chapters 17 and 18 is due. All right. You're not going to have very much homework after this. You're not going to have any hands-on tests. All right. No more this semester. All right. Finally, for chapter 19, the only thing I'm going to ask that you do is the written test for what we're about to go over. And that's due this Sunday. All right. So before we go over any of that stuff, let's see what else we have in here. All right. If next semester, if this is your first semester at Rankin, if this is the first class that you're taking at Rankin in the AWD program, that means that next semester you will be taking AWD 1000 Web Development Technologies. The class begins August 28th, which is what, 5 weeks from today. So this fall semester starts 5 weeks from today. I will be the instructor. We will meet from 8:05 a.m. till 11:55 a.m. And that's a Monday through Friday, as opposed to the Monday through Thursday that we have right now. I sent out version 1, so to speak, of the syllabus. Okay, so I sent out version 1 of the syllabus for those of you who will be in the AWD 1000 class in fall. I sent out version 1 of the syllabus, I don't know what it was, Friday or Saturday. All right, it's about a 30-page document. Okay, for those of you who have already taken that class, I also sent out the syllabus for the AWD 1115 class. So if the first class that you are taking in the AWD program at Rankin is the one we're in right now, the AWD 1100, then you should have gotten sent to you a copy of the syllabus for the AWD 1000 class. If the class we're in right now, the AWD 1100 class, is your second class at Rankin Technical College, then you should have gotten this sent out to you over the weekend. And that is for the AWD 1115 class that will again begin 5 weeks from today. Whereas the AWD 1000 class is a morning class from 8:05 till 11:55, the AWD 1115 class is an afternoon class from 12:05 to 3:55, again, Monday through Friday. All right. What I'd like to do next then is I'd like to go over chapter 19. All right, so that's what we're going to do right now. Now, so everybody sees this, I'm going to go back up for just a second here. Means is we've now completed section 1, section 2, section 3, and section 4. There was no hands-on test for section 4. I want to repeat that. There was no hands-on test for section 4. There will not be a hands-on test for section 5. We are going to go over chapter 19 right now. All right. And my plan is for this class, we're going to skip chapter 20 and chapter 21. And next week, we're going to go into chapter 22. For those of you who starting in fall are going to be in the AWD 1115 class with me. All right, please keep your C# book because during the first week, I plan on going over chapter 20 and 21 from the book. All right, hopefully that made at least some sense to you. So what I'd like to do then is right now go over chapter 19. Now this is all new stuff. An introduction to database programming. All right. Really, the stuff at the beginning, the first 4 or 5 pages, isn't that important, so to speak, as stuff. All right. It's just very general or generic in nature. The heart of the chapter really is going to be pages 610 through 624. So that's what we'll spend the most time on. After we get done with this, which will probably be by 9 o'clock, if not earlier, I'm going to ask that you go in and watch me do this, but I'm going to download a free software tool that'll allow us to start working with databases. All right, we'll get into that in just a little bit. So the chapter is, again, not long. It's not even 20 pages, and it's broken up into 3 sections. An introduction to client-server systems, an introduction to relational database, and how to use SQL to work with a relational database. When you start to work with databases, and we're going to go over what those are in just a moment, there are a lot of different you can use in this class this week. So this week, the week of July 24th, we're going to talk about a database management system called MySQL, MySQL. Next week, the week of July 31st, we're going to talk about something that's called SQL Server. That's another type of relational database management system. The last 2 weeks of class, that is the week of the 7th and the week of the 14th. The plan right now is I'm not going to lecture at all any of those days. That is going to be time for you to work on any work you haven't completed for the class, and also to finish up your final project and your portfolio. All right. Okay, so with that said, let's just get into the beginning here. Okay. Now, what they show you on page 607 in your book is what they refer to as a simple client server system. And it's kind of an interesting picture. It really and truly is. And what I mean by that is, in the past, if you looked at older versions of this textbook, that where it says client here and here, you wouldn't have seen a picture of a tablet and a picture of a phone. Rather, you would have seen three pictures of a desktop or a laptop computer. But times have changed. More people today use the internet and do a lot of their work using either a tablet or their phone. More people do that than actually use laptops and desktops. All right. So, what they're showing here are the three components of what's called a client server system. A client is an end user. So the end user can be using a laptop or a desktop or a tablet or their phone. Okay, it doesn't matter. The network that they show right there is basically meant to be, what we typically refer to as the cloud. That's the internet. For instance, all semester, you've been saving your work out to GitHub. That's saving it out to the cloud. You're saving it out to some network someplace. All right. And the other component there, database server. Now, if I do this, if I go out and just type in this, if I go out to http colon Rankin, it's https colon / rankin.edu. All right, that takes me to Rankin. That's not a database server. That is just a server. All right. Now, I don't even know if this is in here. Let's see. If I go out to the bookstore here, to the Rankin bookstore, and now I say, oh, look, here's a t-shirt for Rankin. Okay, so I find that, and here's a polo, etc. And if I decide I want to go out and order one or more of those, okay, then I am being basically pushed from one server at Rankin to another server at Rankin. Now, if I do come in here and I do start to order these t-shirts, I am going to be working with a database server. Why do I know that? Because this database server is going to have to go take a look into the inventory of shirts at Rankin and says, for instance, let's say that I want to buy a large one of these. All right, but let's say there are no larges in stock. All right, it has to be able to tell me. Or if there is a large in stock and I buy one, it should decrement the number of large shirts like that that are in stock by one. All right. Hopefully, all that just makes sense. It's fairly obvious, I guess. So, typically, when you're a client and you go through the network and you go out to a site, you don't immediately jump to a database server. You jump to a server, and eventually you'll jump to a database server. Another example. All right. And again, I've used this one before. If I go out to Amazon.com, all right, I am not right now, okay? I am not, I'm just out at a regular server. On the other hand, if I decide I want this book by Tim Corey called Getting Started with C, and if I grab that book and I put it into my shopping cart, and then I say I want to check out, now I am utilizing a database server. All right. So, like I said, hopefully that makes sense. So, they say the three components, these are the three hardware components of a client server system. The people who want to use that system to order something or see something, or if let's say you are a prospective Rankin student and you just want to find out some more information about Rankin. So you go out and you bring that up on either your phone or your tablet or your laptop, etc. You're a client. All right. Once you type in https://rankin.edu, you should get back some HTML. That HTML that you get back, that web page, was sent to you by a server. So whereas a client are the personal computers or mobile devices that are used to basically view website information, the server is the computer that stores the files, the databases, etc., to provide whatever the client wants. And then finally, the network is the linkage, for lack of better words, between the two. All right. So as they mentioned there, if you've got a simple client server system, if those of you in this class, if you were coming into Rankin every day, whether it was Rankin St. Louis or Rankin Wentzville or one of the other Rankin locations, you'd see one or more computer labs where the computers are in the same room and are literally linked up to one another. All right. That is what's called a LAN, or a local area network. Okay. However, there's no direct connection between the computers at Rankin Wentzville and the computers at Rankin St. Louis. Why? Well, they're about 40 miles apart. You wouldn't want to lay cabling underneath roads, etc., for 40 miles. So rather than that being a local area network or a LAN, all right, that's a WAN, or a wide area network. Okay. Finally, as it says, when a system consists of a private network and servers over a wide area, it's commonly called an enterprise system. So for instance, if you've ever gone out, let's say to Walmart, and you want to buy something, and you go and look for it, and it seems to be out of stock, and you go up to, I don't know, maybe the service center, and you say, hey, this is out of stock. Can you check and see if any other Walmarts around here have this? Well, those Walmarts are all tied together through an enterprise system. All right. So hopefully that helps at least a little bit. All right. So those were the hardware components. Well, as you know, not only do you need hardware components, you also need software components. All right. Now, you've already got some software components on your computers. Okay. You all have the ability, I would think at least, whether it's a laptop, a desktop, a tablet, or your phone, you've got the ability to go out to the internet, send emails, receive emails, etc. All right. You also, I would think, on your probably your laptop computer, you also have Visual Studio loaded on there. All right. So that's what they're talking about with client software. Now, if we back up for a minute, let's take a look at what this says. So it says, in addition to a network operating system that manages the functions of the network, the server requires a database management system. Now, we are going to look at two of these. We are going to look at Microsoft SQL Server, which is typically just called SQL Server, and we're going to look at MySQL, which is oftentimes called MySQL. We are not going to look at Oracle in this class. It's not a free product. All right. But all three of these that are shown here, Microsoft SQL Server, Oracle, and MySQL, they're all known as relational database management systems, or an RDBMS. If a database system is relational, then the database management system or an RDBMS. If it's non-relational and you learn about one of those, in the AWD1100 class, all right, then you use different types of database systems that aren't listed here. I'll just leave it at that. All right. As it says there, the DBMS, the database management system, manages the database that are stored on the server. It allows users to interface with the database. So as an example of what I said before, if I want to go out to, be it Rankin's bookstore or be it Amazon and order something, that will be in charge of it. All right. That database software is stored on the server. All right. Each client requires application software to do certain things. And I've already given you a couple of examples of that. All right. Those being both C# and Visual Studio is application software. And technically, even your browser is application software. All right. Now, one of the things we've been doing in this course is you've learned how to create your own custom software. That's one of the things we've been doing in this book. As it says, this book shows you how to use C# for developing custom software. Now, we have not done it so far for database apps, but that's what we're going to get into here at the end of the text. All right. And as the author says, although the application software is run on the client, it uses data that's stored on the server. Now, it's a little bit heavy here, so to speak, as it says to make this communication between the client and the server for a C# app, the client uses the database via a data access API. An API is an application program interface. It's, for lack of better words, it's a contract between the user and the software, where the software says, I will provide you with this functionality. And the user says, okay, since you're going to provide me with this functionality, I will agree to use it in the way you want it to be used. All right. Now, we won't talk much in this class about Entity Framework Core or ADO.NET, but we will, like I said, next semester. Once the software, as they mentioned here, for clients and servers are installed, the client communicates with the server. Really, SQL. All right, so we are going to learn in here this week and next how to write structured query language queries. And we will learn how to do them both using MySQL, which we're going to start on today and use for the rest of the week. And also the one that's built into pretty much like a Microsoft product, which is SQL Server. So why am I even showing you two of these? Why don't we just go through one? All right. Well, we're going through two because, first of all, they're very similar, syntactically, etc. They're very similar. You will also use the MySQL in the AWD1100 class, Database Driven Web Development 1, and you will use SQL Server in the two class. Okay. All right. So it says these queries are written in a standard query language called SQL, which actually stands for Structured Query Language. Sometimes it's pronounced SQL. And SQL or SQL, as it says here, lets any app communicate with any database management system that supports it. After the client sends a query to the database management system, the database management system interprets the query, and as long as it was written correctly, it sends the results back to the client. All right. Finally, in that last paragraph, as it says there, the processing done by a client server system is divided between the clients and the server. The more work you give the client, the fatter the client is known to be. And the more work you give the server, the thinner the client. So a fat client typically means a thin server, and a thin client typically means a fat server. All right. Okay, let's continue on then. So again, as it says, for the server software to manage the network, the server runs what's called a NOS, or a network operating system, like Windows Server, Windows 10, Windows 11, doesn't really matter. To store and manage the databases of our client server system, each server requires some type of database management system. All right. And that database management system will be something like Microsoft SQL Server or MySQL. The processing that's done by the processing, see it. The database server is referred to as the back end. All right. On the other hand, the client software, as it says, does the work the user wants it to do. The data access API, I just mentioned to you what an API is, provides the interface between the app and the database management system. The processing that's done by the client is referred to as front-end processing, as the client rather is typically the front end. All right. Finally, as it says here, the application software communicates requests, typically we call, through the data access API. When the DBMS receives a query, it looks at it and it says, okay, was this query written in a syntactically correct manner? And if it says, yes, it was, then it attempts to return the results of whatever the user asked for. And it does this again using SQL, the structured query language. This language, it's pretty impressive. This language has been around since approximately 1970. Now, the reason that I say that's pretty impressive, I can't think of, computers 53 years ago looked totally different than they did today. I remember when I was a senior in high school. All right, that was almost 50 years ago. When I was a senior in high school, all right, we got our first big computer in the offices. And that thing, I'm not exaggerating. If you told me that thing was a minimum of 50 to 75 feet long and probably about 6 feet wide, it was humongous. It made noise, but people thought it was the best thing ever. And to be honest with you, it probably wasn't even as powerful as a phone is today. All right. So this is an introduction next in the next few pages to relational databases. As I mentioned, started in 1970. Dr. E.F. Codd, who was a mathematician, basically is kind of credited with being the person who started all this stuff. Now, one thing that we talked about earlier in the semester is that until we got to chapter 17, where we talked about files, until that time, virtually everything that we did for the entire semester, virtually everything we did for the entire semester, when you'd run a program, let's say you create a program, you ran it, and it works. Great. But your output went away as soon as you basically stopped running the program. All right. It didn't last. The data did not persist. When we got into chapter 17 and talked about file I/O, we talked about one way of making data persist. Databases are another way of making data persist. All right. And again, approximately 53 years ago, this Dr. Codd created really what was a mathematical model that became the relational database model. And as it says, it eliminated some of the problems that were associated with standard files and other database designs. You're going to actually see this in a little bit. By using this relational model, as it says, the first thing you can do is reduce data redundancy. And that's good. Not only because, as it says, it saves disk storage and leads to more efficient data retrieval, but reducing redundancy is also a good thing because, in the past, if you told people to store names in a database, sometimes they do it first name, space, last name. Other people might do it last name, comma, space, first name, etc. So it does remove the redundancy. It removes the complexity as well, or can remove some of the complexity. And finally, as they say there, you can also view and manipulate the data in a more intuitive and efficient way. So before we even go into this, let's just talk about a couple things that, at least my hope is, will make sense to you from the get-go. All right. These are my definitions. There's nothing special about them. I'm not saying they're fantastic or anything else. But if I said to you, basically, for lack of better words, what's a character? All right. And basically, for us, it's any keyboard character. So it's A through Z, A through Z, 0 through 9, and special characters like a comma, an asterisk, a dollar sign, a pound sign, an at sign, etc. Those are all of the characters. Okay? And that may not sound like it's important, but it kind of is. Why? Because if I take one or more related characters and I put them together, I get what's called a field. So for instance, if I put JEFF together, I get Jeff, which is my first name. So it's first name field. If I put SCOTT together, that's Scott, my last name. There's a last name field. All right. Now, if I take one or more related fields and I put them together, I get what's called a record. So for instance, if I've got 10 people in a class, all right, and I've got a list of, for the 10 people, let's just say I've got their rank and ID, their first name, and their last name. If there were 10 people in the class, I'd have 10 records. All right. Then next, we get a table. And a table is one or more related records. Again, these are my definitions. Will they totally jive with what we're about to look at in a little bit in those articles I gave you, etc.? No, maybe not 100%, but they pretty much will. All right. Finally, and this is where we're going to, you get a database, which is one or more related tables. So a field can be as small as one character, somebody's middle name or middle initial, I should say. A record can be as small as having just one field in it, a social security number, let's say. A table can be as small as having just one record in it. Maybe it's a brand new company and the person who owns the company is the only employee in there. Finally, a database can be as small as one table. All right. So again, these are my definitions. There's nothing at all special about them. But they're all things that really each and every one of you in this class should be able to understand. So when I talk about a character or a field or a record or a table or a database, like I said, they should, oops, guess I don't want that, all make sense to you. Here we go. All right. So keep that in mind as we get started here, for lack of better words. So they talk in here about how a table is organized. Okay. And again, remember what a table is. It's one or more related records. So let's take a look at a table on the next page here. Here's an example of a table. All right. A table is made up of rows and columns. Each column is a different field. So we've got 4 fields in here. One field called product code, one field called description, one field called unit price, and one field called on-hand quantity. All right, so fields basically, they're the columns. All right. Then you've got rows. The rows are the records. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 rows or records of data in here. If this was complete, let's pretend at least that it is, 16 rows, 4 columns per row. When you do the math, 16 times 4 would say that there are 64 pieces of information in here. Now you'll notice if we look at product code, up above it, it says primary key. I like to, whenever possible, make my definitions when I go through this stuff as simple as possible. Remember, each row in here is a record. So here's a record right now where the product code is C#, the description is Murach C#, the price is $59.50, and the order or the on-hand quantity is $43.47. So a primary key is what we would refer to as a unique record identifier. Each primary key must be unique. And you can see each one of these is. So again, whoops, sorry. All right, let me move these. I'll make it a little smaller. All right, so again, a primary key is a unique record identifier. And for records, so fields in here are also known as columns. And records are also known as rows. These are not my terms. These are just pretty much standard database terminology terms. Okay? All right, so as it says, a relational database uses tables to store and manipulate data. What we're going to get to in just a couple minutes is when you do this, one or more of the tables in the database, ideally all of them, will be related to one another, either directly related or indirectly related. If you don't understand what that means, again, please just bear with me a couple minutes because we're going to talk about it in more depth and breadth of coverage. So as it says, each table consists of one or more records or rows that contain data for a single entry. Each row contains one or more fields or columns, which represents a single item of data. Very similar to what I just gave you right here. Most tables, as it says here, contain a primary key that uniquely identifies each row in a table. What did I just say what a primary key was? It is a unique record or row identifier right there. Right? The primary key usually consists of a single column, but there may be reasons it needs to be two or more columns. If the primary key contains two or more columns, it's called a composite primary key. It even goes by other names, but composite will be fine for what we're doing. Now, let's suppose that we had a list of 25 employees. All right. And each one of those employees, as you guess, would have both a social security number and they would have an employee number. Technically, each one of those fields, both the employee number and the social security number, ideally, they should both be unique. I would never, ever, ever choose as a primary key social security number. A primary key should be what's referred to as unintelligible. Unintelligible. What that means is if somebody figures out your primary key, you shouldn't be worried about it. And if somebody figured out in here what a product code was, I probably wouldn't care. But if I was foolish enough to use a social security number for a primary key and somebody found it out, many bad things could happen. So primary keys should always be unintelligible. All right. In addition to primary keys, some database management systems allow you to create non-primary keys, something called a unique key. So even though I would not make social security number a primary key, I'd give it a unique key designation, which meant that everybody must have a unique social security number. Finally, as it says here, A table can have one or more indexes. Indexes provide an efficient way to access table data. Indexes are automatically created for any table's primary key and non-primary key. Now, when you think about it, if I said to you, okay, what's a primary key? And let's just say you didn't know what page it was on or whatever. What would you probably do? But you knew it was in the book. I mean, if it was me, I'd go to the back of the book, I'd look in the index, and I'd look up primary key. It would push me to this page, and it would say, look, there's a primary key. All right. Now, I mentioned, and this is the whole idea behind a relational database management system, and that is the fact that the tables in a relational database management system are related. And they're related either directly or indirectly. All right. Now, they're going to show an example right here. And it's a pretty simple example. Whether it looks like it or not, it is. But just for a second, I'm going to come back to here and I'm going to go to our projects. All right. And there's a reason I'm doing this. We're not going to go over any of this, but I want to show you something. And that is if we get down towards the bottom here, here is the database system that is used by Murach. In fact, to my knowledge, it's the one that's going to be used. Those of you who next semester are in the AWD1100 class, I believe this is the database we'll be working with. You'll notice that it has 6 different tables. A table called customer. Customer has 3 different, or I'm sorry, 3, 4, 5, about 8 different fields in it. A customer ID, a name, an address, a city, a state, a zip code, a phone number, and an email. In addition, it has a primary key of customer ID. Then we've got a states table that it looks like has 4 fields in it. A state code, which is the primary key, a state name, a first zip code, and a last zip code. I'm not even sure what those are. All right. Then we've got another table called incidents, which again has about 8 fields in it. An incident ID, which is our primary key, a customer ID, a product code, a tech ID, a date opened, a date closed, a title, and a description. Then we've got a registration table that has 3 fields in it. A customer ID, a product code, and a registration code. Next, we have a products table, and that products table has 4 fields in it: a product code, a name, a version, and a release date. Finally, we've got a technicians table with, again, 4 fields in it: tech ID, a name, an email, and a phone. You'll notice as you look through this, the first column is always the name of your different fields in your different tables. The second column is the data type. And you'll notice a data type you probably haven't seen before. Or maybe even a couple. The first one is varchar. Varchar just means it's a variable length field. So name can be between 0 and 50 characters. Address can be between 0 and 50 characters. Then if you get down to state, you'll notice it's a char. That's a fixed length field. That says that each and every state will have 2 characters. All right, you'll notice that all of the IDs, I shouldn't say that, I'm wrong, that most of the IDs the ID for the customer table, the ID for the incidents table, the ID for the registrations table, and the ID for the technicians table. So 4 out of the 6 IDs are of type integer, whole number. The IDs for the state table and the one for the product table, all right, those are both type char. But since they're primary keys, each must be unique. You'll notice if you look at the registration table, it has a composite primary key, which is a combination of customer ID and product code. Finally, if you look, you can see that the customers table is related to the incidents table. The customers table is related to the states table. The registrations table is related to the customers table. The registrations table is related to the products table. The incidents table is related to the products table. And the technicians table is related to the incidents table. So you can see we've got information in 6 different tables. Now, there is some repetition here. There is some redundancy, and that is put in there so we can actually go in and do what we want to do as far as relating data rather. All right. So you'll notice, what if my boss came up and said, I want to get a list of all of our customers. I want their name, their address, their city, and their state. But let's just say they didn't want the state abbreviation. They actually wanted the state name. Well, I could go and grab from this table, I could grab the customer name, the customer address, the customer city, and from this table, I could grab the customer's state name. We can do that because we've got a field in common between these 2 tables. There is a state field here that's a char of type 2, and there is a state code here, which is a char of type 2. They don't have to have the same name. They just have to be of the same type. And if we show a size, the size must be the same. So you can see there's that direct linkage between customers and states through the state field. There's another one between customers and incidents, all right, because they both have a customer ID field in them. There's one between customers and registrations because, again, they both have a customer's field in them. I should say customer ID field. There's a relationship between registration and products. They both have a product code field in them. Finally, there's one between incidents and products. They both have a product code field. And one between incidents and technicians. They both have a tech ID field. All right. So as it says here, this database consists of 6 tables. All right. Each row is related to a row in one of the other tables. All right. And the only reason, again, that I brought that up is to show you that's what's known as good database design. All right. So if I keep looking in here, you'll notice that I've got the invoice ID field in both of these tables. All right. This invoice field, invoice ID, is in both of these tables. Who cares? You should. And the reason that that's important is I'm able to relate these 2 tables because they both have the invoice ID in them. So I can pull out any of the fields I want in here and combine them with any of the fields I want in here because both tables have an invoice ID. Now, you'll notice in here the words primary key and foreign key. We've already talked about what a primary key is. We've already done that. It's a unique record identifier. But what the heck is this foreign key? We added the foreign key field to this table so we'd be able to relate the information in here directly with the information that's in there. So when you create a foreign key, you add a field to a table where that field is the primary key in another table. Now, I didn't mention this, but I do want to. Let me go back to, where are we here? This. You'll notice if you look in here, we've got the key, and then always on the other end, you've got a thing that kind of looks like the number 8 that's turned sideways. This means many. This means many. What is that? What do I mean, many? This means that any one customer can have 0, 1, or more incidents. Any state that's in here, I should say, can be related to one state in here. All right? But where these are all one-to-many relationships, where the one side is the primary key, and the many side is this 8 turned upside down. That many side means 0, 1, or more. So again, every one customer can have 0, 1, or more incidents. Every one incident can have 0, 1, or more technicians working on it. Every one product can have 0, 1, or more incidents associated with it, etc. Now, going back to what we just mentioned there with that foreign key, this is a one-to-many relationship. If you take the primary key from your main table, the one side, and you add that primary key field to your child table, which is the many side, you are establishing a one-to-many relationship. That's what a foreign key is. A foreign key is when you take a primary key field from another table and you add it as a field in your table, so you're able to relate the two tables together. And if you look in here, there should not be a field that's in here that's not in here. So we've got 41, there's 41, 42, there's 42, 43, there's 43, 44, there's 44, 45, there's 45, 46, which is in here 1, 2, 3, 4 times, and 47, which is in here 1, 2 times. So as they mentioned right here, the tables in a relational database are related to each other through their key columns. All right. And it's what I just told you. Usually, as it says, almost always, a foreign key in one table corresponds to a primary key in another table. But it is possible that a foreign key can correspond to a unique key. Don't worry about that for right now. When two tables are related using a foreign key, the table with a foreign key is called the foreign key table, sometimes called the child table. And the table with a primary key is called the primary key table, sometimes called the parent table. What was shown when I went back and showed you this, these are called one-to-many relationships. One-to-many, 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 and one-to-many. It is possible to have other relationships, not just one-to-many, but you can also have one-to-one relationships and many-to-many relationships. All right. If you were really setting up a database in the quote correct way, unquote, if you did it that way, all the relationships between tables would be one-to-many. But life isn't always perfect and things don't always work out the way you think they should work out. All right. So again, there are three different types of relationships, but the one that you are shooting for most of the time, all of the time, if possible, are one-to-one relationships. All right. So how columns in a table are defined? Well, that's what I refer to typically as the data types. Again, when you look in here, invoice ID, customer ID are both ints. Well, you know what an int is. We've dealt with those all semester. They're integers. All right. Invoice date is a date time field. All right. Product total, sales tax, shipping, and invoice are money fields. What the heck mean money fields? Kind of like a decimal that we've been working with. Now, the stuff that's in here is probably going to confuse you. But the keys, it says there's one, and it's showing that invoice ID is the primary key. And it also says there is a foreign key in here, which is the customer ID. Don't worry for now, at least, about the other stuff that's in there. But when you go in and you create a table, each field in the table needs to have different data types. Some of those data types are shown right here. I'm not going to go over any of them right now. But as they mention underneath this in the description section, the data type that's assigned to a column determines the type of information you can store or that column can hold. All right. Each column definition, as it says, also indicates whether a column can hold null values or not. Well, you'll notice none of these are checked. So none of these are allowing null. Null just means unknown. So for instance, if we had this checked where we have here the invoice date, that would say that it's possible that you don't know what the invoice date was. And you'll notice in here, there's even a thing for default. I have mentioned this kind of example to you before where I said, as an example, all right, that if I was writing some kind of an application for Rankin Technical College, I might default the state to Missouri because approximately 90 some percent of the people who go to Rankin are from Missouri. All right. And again, as it says there, again, with the default, it says a column can also be defined as an identity column. All right. What does that mean? Well, to give you an example, maybe not the best one, but it's one I've used before. I remember years ago, I had moved to Illinois, and I wasn't there very long. One of my first days there, I went, I didn't have my bank accounts or anything set up yet. Okay. But when I went to go, I stopped at a gas station. And when I went to fill up the gas, there was a sign on the pump that said, checks welcome, must start with number 500 or later. All right. And I asked the guy, why did you do that? I kind of knew, but I asked him anyway. And what he said was, well, we started at 500 because then it's not a brand new checking account. So I was smart enough that when I set up my checking account at a bank in Illinois, I said, hey, can you start my checks at number 1000 instead of number one? They said, yeah, no problem. All right. So with an identity column, typically when you add a new record, that identity column will be incremented usually by one. So in the same way, the first check that I had was check 1000. The second check was check 1001. The third was check 1002, etc. You can also set what are called check constraints. Why would you want to do that? Well, for instance, maybe a customer ID, all right, maybe it must be at least 300. Maybe an invoice at least 1,000. Maybe the date can't be earlier than today's date. Maybe a sales tax can't be more than maybe 25%, something like that. So those are all things that you can set up as check constraints. All right. Finally, the note on the bottom of the page, as it says, when you select a column in design view, its properties are displayed in the properties window. Okay. All right. Now, there's going to be another database that they deal with in this book. All right. It's an MMA database. I don't know for sure what MMA stands for. All right. I don't think it's mixed martial arts, but the first M might very well be Murach. I don't know. Don't care. All right. It says, though, that figure 19.6 that we're going to look at in a minute shows the design of the MMA database that we'll use for really the rest of the book. So if we go and look on the next page here, here's our database. This is not the same one I showed you earlier. You'll notice again, there are 6 tables. Now, what isn't great, so to speak, is the order options table. When you look at that, has no field that it is in there that's in common with any of the other fields. I often say that the order options is kind of like out on an island by itself. The reason that that's important is there's no way to directly link order options with any of the tables. All right, which may or may not be a good thing. How would you do that if you wanted to link them? Well, I could come up and take customer ID, which is the primary key here, and I could add it in here as a foreign key. Then those would be related. You'll notice that the other tables, there is a one-to-many relationship between states and customers. There is a one-to-many relationship between customers and invoices. There is a one-to-many relationship between invoices and invoice line items. And there is a one-to-many relationship between products and invoice line items. But there is no relationship between order options and any other table we have in here. So this is the one that they're going to use, I believe, for the rest of the book. We don't have that much of the book left. We're on chapter 19 out of 22. The customers table contains a row for each customer. Its primary key is the customer ID. Already saw that. It's an identity column. So if it starts with 1, doesn't matter really what it starts with, but every time we add a new customer, so let's say it starts with 1,000. So the first customer will be customer 1,000. The next one will be 1,001. The next one will be 1,002, etc. And you can do that for each one of these if you want to. The state is a foreign key that relates each customer to a row in the states table. Then you've got the invoices table here. right? And as it says, it contains a row for each invoice. Its primary key is the invoice ID. And again, that's an identity column. The customer ID is a foreign key. So customer ID was added as a foreign key because it is a primary key in this table. The invoice line items contains one row for each line item of the invoice. So for each item the invoice contains. The products table contains a row for each product. The states table, a row for each state. The order options table, a row that stores the sales tax and shipping charges used by the app. All right, and then we've got our relationships. Now, again, you'll see in here, if we look, for example, we've got, there's a relationship between invoices and invoice items. Every one invoice can contain 0, 1, or more invoice items. And that is the same relationship that we saw here. Invoices and invoice items, a one-to-many relationship. How to use SQL to work with a relational database. All right. Once we finish this chapter, we're going to take a short break, and then I'm going to show you a tool that you can use to work with this. All right. So as it says here in the topics that follow, we're going to learn about 4 different statements that you can use to manipulate the data in a database. Those 4 statements are also known as CRUD operations. CRUD. They are select, insert, update, and delete. CRUD actually stands for create, read, update, and delete. Now, these statements that are mentioned right here, these 4 statements, we'll go back to what we had here before, and we hit enter quite a few times here. All right. But when I look at what's in here, and I look at these statements, so select, insert, update, and delete. All right. These are known as DDL, or data definition language statements. All right. And they're also known as CRUD operations, where C is create, R is read, U is update, D is delete. Now, again, this isn't something I'm making up. So you are working with the actual language, the statements that are in there, the data that's in there. You are defining the data that's in the database. So you use one of these 4 data definition language, or DDL statements. Select, all right, which is like read in CRUD. Select allows you to look at the data, but you cannot change it. Insert, which is like the create in CRUD, allows you to make new data. Update, which is the same in the CRUD, allows you to change existing data. And delete, which again is the same inside of CRUD, allows you to delete or get rid of existing data. Now, what you're going to learn in a little bit is not only are there 4 DDL statements. All right, but there are three, and they are create, alter, and drop. Those are called DML, or data manipulation language statements. All right, and they allow you to create, modify, or remove what's called database schema. You're going to see that after the break. All right. I will take this piece of paper where I'm putting all this stuff, and let's save it. We'll save it into our desktop, and I'm going to call it more DB terminology .txt, and I'll send you this. You already have it, believe it or not. You have most of it already. All right. So as they mention here, in the topics that follow, we'll learn the 4 DDL statements, those being, again, select, insert, update, and delete, which again allow you to do what's called CRUD operations. All right. It says, basically, it says in here, hey, we're only going to give you an intro. They've also got a book called Murach's SQL Server for Developers, which we don't use. Right. Now, as mentioned here on the top of the page, each database management system has its own syntax, or what they call its own dialect. You don't have to worry too much about it. And what you're going to see is today, tomorrow, and Wednesday, we're going to look at the dialect or the syntax for using the MySQL relational database language. Next week, we're going to look at the dialect, all right, or the syntax for using Microsoft's SQL Server database management system. So the first thing that they talk about in here is how to query a table. All right, so imagine that you had a table that it had, let's say that we called it students. All right, and each student had an ID. Each student had a first name. Each student had a last name. And each student had a grade. We'll just keep it real simple. All right. So let's, okay. I'm just going to literally show what that table might look like. So I'm going to keep going in here, and I'm going to create a student table. And we're going to say we're going to have a student ID, and that's going to be of type integer. And then we'll have a first name, and that will be of type varchar, which means it can vary. And we'll say 20 characters. All right. Then each student has a last name. And again, it'll be a varchar. And again, we'll say about 20 characters. And finally, each student will have a grade. And we'll make this a decimal type. All right. Or it depends. If we want to make it, we could just literally, we could make it a varchar of 2. Now, I didn't make it a char there. We could make it be just a char of 1 where you get an A, B, C, D, or F, but then we wouldn't have plus and minus grades. That's why I did it that way. All right. So we could create it. This right here, right there, that's what would be known as our database schema. That's actually the term that's used. All right. And the way that we would end up creating that is we would use the create statement. You're going to see it in a little bit. But again, this allows you to work with database schema. Then if I put in the records, let's say we've got 5 students. All right, so student has an ID of 1. All right, their first name is John, their last name is Doe, and their grade is an A. Then we've got a statement, and we've got Jane Smith, and let's say she's also an A. And then we've got Mark Kent, and Mark's getting a B. And then we've got Mary Jones, and let's say she has a C. And then we have, I don't know, Ken Brown, and he's getting a D. Finally, we've got Jean White, and she's getting an F. I'm just making these up, right? So this would be my data right here. If I wanted to see, so in other words, we're going to say that this right here was our student database schema. And then here, this would be our student database data. So if I decided I wanted to query this database and I wanted all of the data for every student, I would type in select star from students. Now you don't have to do this, but I tend to, when I'm writing queries, take keywords like select and from, and I capitalize them. I take words that are not keywords, like students, and I don't capitalize them. Now that's going to literally give me something back that looks like this. And it'll say here whatever the name is. So it'll say student ID, and then it'll say first name, then last name, then grade. What if I don't want all that stuff? What if all I want is the first name and the last name and the grade? Then I have to list out the fields. So I'd say select first name, last name, grade, and I could put this on multiple lines from students. All right. And that would give me the same thing as this, except the numbers wouldn't be shown. So imagine I did this, and then I try to come in there and hide those numbers there. So that would give me this. All right. If all I wanted were the names, then I would say select first name, last name from students, just like that. And then I would just get John Doe, Jane Smith, Mary Kent, Mary Jones, Jane Smith, Mark Kent, Mary Jones, Ken Brown, and Jean White. All right. And there's a lot of other stuff I'm able to go in there and do as well. You're going to see examples of this after we take the break. And I know that this has been a long lecture. I've already been going for an hour and a half, but it's probably going to take around a half an hour more. All right. And I'm going to go till noon today. All right. After noon, I'm going to stop. And then I am going to do, I said this morning, and I said it in the email that I sent you at the end of last week. I am going to go in and I'm going to write a version of the test that you took last week with the loans, and I'm going to do it from scratch. If you have not turned in a test, you must turn it in by 8 a.m. tomorrow. Even if you haven't turned in a test yet, all right, I'll still give you partial credit. Now, how do you know if you've turned in a test or not? You go out to your inside Rankin and you look at your grades. All grades, everything that was turned in through last week, Thursday. That's the 20th. It's all been graded. If you turn in something Friday, Saturday or yesterday, it has not yet been graded. All right. So to query a single table, it depends on what you want to do. When you use a select statement, you get what's called a result set. And I already showed you some of those result sets. When you do a select star, you get everything. You get everything that's in the table. And that's what they say in here. All right. Instead of doing that, if you only want certain things, you can do that as well. So notice here in this example, they give the name and the city. You could have said star there too if these are the only two fields from that table. But here they're saying where the state is equal to Washington. So these are all cities in Washington. And there must be at least one more field in here. There must be a name, a city, and a state. But we're not listing out the state, but we are using it in here to make a check. The where statement that you see in here, that where statement allows you to put criteria into a select statement. Right? Remember, select does not change data. It only displays the data that you asked for. So you select either everything with a star or you list them out a column at a time. From is followed by the name of a table. It can also be followed by something called a view, which we're not going to get into right now. Where can be used to add criteria to what we're about to select. And order by can be used to put things in some kind of an order. You'll notice here we've ordered them by name. So notice these are in alphabetical order. All right. So let's take a look at the examples that I just gave you. All right. And let's say you'll notice that right now, let's change this around a little bit because right now they are actually in alphabetic order. So let's say that John had some tough times and now has an F. All right. Jane has got a B. Mary, she's now got a C plus. And Ken really put it together and he's now got an A. You'll notice that now they're not in any kind of order. If I want them in order based on the grade, if I want to show everything, in fact, let's just say we want first name, last name, and grade, but we want Ken first because he's got an A. Then we want Mark Kent because K comes before S. All right, and then Jane Smith, etc. Okay, so how do we do that? Well, we can come in there and say select first name, last name, grade. And since we're not using the ID, we don't put a star in here, we list them out. All right, so those three fields, whoops, from students, but now I can say order by grade. Now, if I say order by grade, it automatically adds that in there, which means ascending order. If I wanted it in descending order, then I must type in this. So I want it in ascending order so I can either leave it like this or do this. And that is again going to show me then Ken Brown A, Jane Smith B, Mark Kent B, but we said A. These people both got a B. We want Mary or Mark Kent to go first because K comes before Smith. So I can say order by grades, and then if there's any tie on grades, I can do it by last name. All right, so I can order by as many fields as I wish to order by. So this will give me the first name, the last name, and the grade. but the order in which it gives it to me should be, okay, it should come in here and it should say Ken Brown A, then Mark Kent B, Jane Smith B, Mary Jones C plus, John Doe F, Gene White F, in that kind of an order. All right. If I wanted them to be in reverse order for the grade, all right, a John Doe F, F, then Mary Jones C plus, etc., I would change that to descending. And remember, when I do use ascending, this, putting that there is not mandatory. But if I do want something in descending order, then it is mandatory. All right. So the result you get back is typically referred to as a result set. All right. It says when you do a select, now we don't have an example of this here, you can also create calculated columns. We'll talk about that later. The from, as it says, tells the table that you want to grab data from. The where, again, allows you to put criteria on your search. The order by allows you to put something in ascending or descending order. And the asterisk, put that in there, says, show me everything. All right. Now, we're almost done, but this is a little harder. What do I mean? Because what this does is this allows you to join data from two or more tables. All right. Well, let's go and add another field. Let's go in and add another field to what we were just working with. All right. So I'm going to grab this and I'm just going to make a change to it. So I'm going to come down here. I'm going to keep everything I've been doing here. And I'm going to add another field to this. Whoops, I don't want the data. What did I do here? All right. I'm going to grab all of this that I had from before, every bit of it. And I'll put a little delimiter in here. So I'll put in these just so you can see that I stopped. And now I'm going to kind of redo it. So we'll call this student 2 database schema. And this will be student 2 database data. Okay. Well, let's say that what we wanted in here was the program the student was in. Hopefully you're with me here. We want the program that the student is in. So after the grade, we're going to put in here program. And we're going to make it a varchar. And we'll make it 25. All right. So I'm going to move this out a bit. And we're going to assume that John is in the application and website development program. That's probably more than 25 characters. So let's make that 50. All right, that should be less than 50, I would think. All right, we're going to suppose rather that Jane is in the plumbing program. All right, we're going to assume that Mark Kent in here is in the networking program. All right, we're going to assume that Mary Jones in here is also in the networking program. All right, we're going to assume that Ken Brown is in the electrical program. I'm just making this up as we're going along. And we'll say that Gene White is also in this program right here. All right, now imagine that we have thousands of these students. All right, we're doing it over time, or we've got tons of campuses. There's probably a good chance if people are going to enter this manually, they're going to make mistakes. They'll spell application wrong or something else. It's just probably going to happen. Can we make this a little easier for us to work with? Well, we're going to assume right now that we only have 4 programs. This program, this program, this program, and this program. I know Rankin has more, but to make it easy, we're going to assume, all right, that we have 4 programs. So we're going to call this schema 1. And then I'm going to come in here and I'm going to do schema 2. And if you say, I don't understand, well, then just bear with me if you would for a second. All right. And let me go down here and I'm going to say, well, let's say that if they're, we're going to call it this, we're going to call it program code. Okay. And that will be an int. And we will also have a program name. And that will again are of size 50. 50. There we go. So program code, I'm going to run those together. I'm going to run these together. All right. So now I'm going to change. So my student 2, so this is going to be student 2 database data 1, we'll say. And now I'm going to come up here and put in student 2 database data 2. Right? And it's going to look like this. We're going to say 1, and I'm going to grab this. We'll put them in alphabetical order. They wouldn't necessarily have to be. And then 2 will be electrical. Then 3 will be networking. Like I said, we have more programs than this at Rankin. I'm just doing this. Hopefully it all makes sense to you. And 4, which will be plumbing. Now I can change this. So this is a 1. This is a 4. This is a 3. This is a 3. This is a 2. And this is a 1. Look at how we've cut this down. All right. There's much less of a chance of me putting the wrong number in as there is of me spelling something wrong in there. All right. Now, the problem comes in is my boss now comes up to me and says, hey, I want you to go and I want you to give me a chart like this, but I don't want those numbers. I want the actual program those people are in. All right. And I'm going to show you 2 ways of doing that. I want to grab the one that they have here. So let's see. I don't know if they have another example or if that's the only one. Yep, this is what I want. All right, because I do it a different way than what's shown in the book. There's the way the book shows it is the more or less newfangled way, and what I show is more or less the old fangled way. Okay, so we're going to say here, select first name, last name, grade, and program. All right, from, now we have to say what we're using. Well, this all comes from data 1, we said, and this is data 2. All right, so data 1 and data 2. So we are grabbing data 1 dot first name, data 1 dot last name, data 1 dot grade, and data 2 dot program. All right, we want this from which tables? Our data 1 table and our data 2 table. But now we have to say, how do we want to do this? Well, got to do this a little bit differently. And that is we say grab it from data 1, and then we say inner join on All right, so inner join data 2 on. So what field do they have in common? Well, this has a program code in it, and this has a program code in it. All right, so we've got a program code in each one of these. All right, we're going to make that, let's see, we're going to make this program code, and that's going to be our varchar, whatever we made that code, it's an int. All right, so now we can say do this, and we need a field in common. What do I mean? We've got to say join it on data1.program code equals data2.program code. And that's going to give me back so that will give me back exactly what I'm looking for. Now you might turn around and go, okay, I even kind of get that, but it seems like a hell of a lot of work. Why don't I just put everything together into one table? Because sometimes when you're working, think about this. If you've got an employee at a company, you could have, for example, social security number, employee number, first name, middle initial, last name, address, city, state, zip code, phone number, department that they work for, salary. That's 12 fields already. And there could be a lot more than that. So this is called a table join. We are grabbing information from two different tables. So in here, we grabbed information from both the product table and the invoice table. All right. Now, notice they talk in here about using IDs. What does that mean? Well, if we wanted to, this isn't a lot to type in there, but if we wanted to, we could do this. We could just say D1, 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 and D2. But then we'd have to say those are aliases. So call that D1, call that D2, change that to D1, and change that to D2. What I'm doing there is what's typically referred to as aliasing, because sometimes table names can be long. All right, so it can be much easier to read like this. Okay. All right, so that again is a join. So a join, as it says, lets you combine data from two or more tables into a single set of results. The most common type of join is an inner join, which is what I just showed you. It's also called an equijoin. There's also a non-equijoin. There's a left join and a right join. We're not going to talk about those all right now. Finally, as it says there, you can make aliases. All right. All right. So far under these select, update, select, insert, update, and delete, the only one we've looked at has been select. So under these CRUD operations, create, read, update, and delete, the only one we've looked at has been read. But you can also insert, update, and delete as well. Let's take a quick look at those. And I believe after this page, we're done with the chapter. So we'll take a break in about 5 or 10 minutes. All right, that works out well. So let's look at these. So let's say I wanted to add a new record. All right. So let's say that I've got a new student. And in here, I've shown you the finished product already. But I want to add a new record into data one. So I want to add a new record. So I'm going to say insert into the name of the table, which we call data one. All right. Then what are our field names in there? They are the ID, the first name, the last name, the grade, and the program. Well, if we set up the ID as basically what you typically would refer to as auto increment field, we don't have to even add that. The next one we put in will automatically be 7. All right. But what I'll put in here, I'll put me in. So Jeff, Scott, let's say I got a D plus, and I am again, let's say I change programs and now I'm in the networking program. That's how I could do an insert. So remember what I'm inserting into. Come on, which is here. So I need a first name, I need a last name, I need a grade, and I need a program. All right, I've got all those. I don't need the ID because we set that up as basically what is referred to as either an auto increment or an identity column. All right, well, guess what? When you put that information in, I didn't really have a D plus, I really had a C plus. All right, so I want to change that after I put it in. So after I put in this information here, after I put that in, I'll now have up here 7, Jeff, Scott, D plus, and I'm in number 4. I'll have this after this. So that's how you can do an insert. Then we've got an update, where we say update followed by the table name. All right, so I can say update data 1. Then I can say set. Now I'm going to show you the wrong way of doing this. I'm going to say set grade equal C plus. If I do it like that, that's going to change everyone's grade to a C plus. I only want to change mine. So you might say, oh yeah, then just do it, say like where first name equal Jeff and last name equal Scott. And actually, yeah, that would work. But what if I have more than one Jeff Scott in there? God forbid. So I really shouldn't do it like this. But if I know that Jeff Scott's ID is 7, all right, if I know that let's just call it student ID is 7, I can just change it to where student ID equals 7. So there, that would change this. So I now have in here a C plus. Finally, if I wanted to get rid of that, I could say delete from data 1 where, and I'd say the same thing here. And you have to always be leery. You have to always be leery when you do this because you're not asked. You don't get a thing that comes back that says, are you sure you want to delete this? If you delete it from the database, it just deletes it. So there is an insert, there is an update, and there is a delete, which are other operations. And now they actually have other examples in the book here with the examples that they used. So as it says, you use the insert, update, and delete to maintain data in a database. Makes sense. The insert is used to add one or more rows to a table. The update and delete are used to either update existing table data or to delete existing table data. All right, so I believe that we said that's it for the chapter. Longer than I thought it would be, but that's fine. All right, when we come back from the break, we're going to start seeing how we can work with this kind of stuff ourselves. All right, I want you, if you would please, to go out to a site that's called APACHEFriends.org. It'll look like this when you get there. And here it is if you need it to be a little bigger. Well, not there, but all right, you don't need this. You just need the APACHEFriends.org like that. I believe that's all you need. So let's make that nice and humongous. There you go. So I think if I just type in here, APACHEFriends.org, it's going to bring me to the same place. Well, if I type it in correctly, APACHEFRIENDS.org. Hit enter. There we go. All right. So it is 9:59 right now. We'll take a break. Let's come back at 10 after 10. I'm going to refresh my water. All right. And we'll pick it up there. Okay. So I'll see you in about 10 minutes. All right, as you can see on the clock here, it is now 10:10. So I wanted you again to go out to ApacheFriends.org. And if you go out there, this is what you should see. And we're going to download a XAMPP for Windows. Some books call this XAMPP, some call it XAMPP. There are other versions of this. There is an XAMPP, which works on Linux or on Mac or on Windows machines. There is WAMP, which is one like this just for Windows. There is MAMP, which is one like this for Mac, etc. But this is the one I've been using for years and never really had problems with it. So where it says download, I have removed mine, so I'm going to re-download the newest version. So I'm going to click on here where it says XAMPP for Windows, and it should show it down here in the bottom left-hand corner. Maybe not. All right, so let's see. Your download will start automatically. If it doesn't, click here. I don't see it. There it goes. So I'm going to right mouse click on here and I'm going to choose open when done. It may come back and beep at me telling me that I need to have administrator permissions, and I'll just tell it, yes, I want to continue anyway. All right, I told it to open it up when it was done. So it says opening when complete. So it's just about there. All right. So if you get this, just type it and it's going to start doing the download for you. All right. Now it says here important because a user account on your system has some functions on there. Please avoid to install XAMPP to program files, missing write permissions. If you get something, you shouldn't get that. I just did because I had this on here. All right, I'm gonna still go through all of the defaults. It should still work. Next, you want everything that's here. And actually, you don't need Perl. You don't need Tomcat. The only thing you need here from here is MySQL. You don't need FileZilla. You don't need Mercury Mail Server. I'll leave Tomcat up there. All right. Heck with it. It's not that big. I'm just going to leave it all up there. Okay. Next. Yeah, I'll put it here. Next. Yes, I want it in English. Now it should be going through and starting to get ready to do the install in just a second. There it's installing. Now I might get an error because I thought I'd cleaned out the directory where I had all this stuff. Evidently I didn't, but hopefully I won't get any error. And usually it takes about 30 seconds. I don't know if my connection is slow today or what, but yours might take a little more time than mine. Yours might take a little less, depending on your connection and whatever. The whole process of us going through this should take less than 5 minutes. It says there XAMPP or XAMPP is an easy to install Apache distribution containing MySQL, PHP, and Perl. The only thing we're going to be using from here is going to be Apache and MySQL. We will not be using PHP. We will not be using Perl. So you really didn't need to load either of those, but it's okay. It's not going to hurt anything. Also, when you get done with a class, if you want to get rid of this, okay, we will not use it next semester in the 1115 class. I don't know in the 1111 class if it's used in there or not. I don't think so, though. Again, it's slower than it normally is, but it's already more than halfway through or around halfway through right now. Years ago when I was teaching in a different college, I literally had a student who got an error message when he tried to download it. It was in the classroom. We tried to debug it, and then we just kept trying, and finally I said, well, I'll tell you what, just watch with a person next to you and we'll work with it after class. Unknown to me, he just kept trying to do the install over and over and over and over and over and over again. And he finally told me that it took on the 17th try. Why? I've never seen anything like that before or since. With literally 100% of the students, other than this one student, it's always worked on the first try here. All right, looks like it's about 85% done. There are a bunch of options that you can set in here. I'm going to try to make this as simple as possible. This is the icon for it. To me, it looks like a dog bone. You may or may not agree with that. I've heard it say it looks like a frowning face or maybe even a little dog or something. I don't know. Just about finished here. All right, so it's complete. Do I want to start the control panel now? I'm going to say yes. Then click OK, and you'll see the control panel. There it is. All right, and okay, it's no biggie, but you don't ever have to do this. It really doesn't pay. But what you want to do to get this started is you want to come over here. There's going to be three things you have to do. These first two start buttons, and this is for Apache and for MySQL, you'll want to click on both of those, and they should both change from looking like they are now. They should both become green and say stop, which will turn them off if you click it again. So this should say stop in just a second. Oh, I guess it's just doing it green here. And the same thing here, stop, and notice they're both green. That's good. The only other thing that you'll want to do, so click that one and that one. You can see again, that turned them off. So click start on the same line as Apache, click start on the same line as MySQL. Then right next to the one you just clicked for MySQL, click where it says admin. This is going to bring up this right here. This is called PHP My Admin. All right. This is a semi-GUIized thing where you can create databases. What I'm going to do is run through, and that example that I just did for you, for lack of better words, kind of longhand, this thing, I'm going to go back and I'm going to redo this, but I'm going to redo it using PHP My Admin. The first thing I want to do is I want to create a new database. So I can click there, or I should be able to click here also. All right, and give it a new name. I like to just, to me, it makes the most sense to click right there. So it asks for a name. It says these are the names, these are the ones that come with the system. Information schema, MySQL performance schema, PHP MyAdmin, and test. I'm going to recommend just leave them alone. Don't look at them, don't touch them, don't do a flipping thing with them. All right, so my database name, it likes it all in lowercase, it looks like. So I'm going to put in here students. And this is basically the UTF. It's the Universal Transformation Format. It says that we're basically setting this up. What's the word I'm looking for? Oh, crap. Not with ASCII, but whatever came after that. All right, just leave it the way it is. So students, and then click create. And you'll notice I now have a new database right there called students. If I click on it, okay, it says, now what do you want? I'm going to add two tables. All right. And the going to be this one that we looked at before. it's going to be this one. So we'll have a first name, a last name, a grade, and a program code. Okay, so we're going to have, and actually I'm going to make an ID in there also. Remember, we had an ID up here. So this will have a student ID, which will be an int, a first name. Let's just make everything all lowercase, except where we run two things together like this. So F L G E, like that. And we'll make this a P and this a P, like that. What I'm about to create right now. All right. So this has got 1, 2, 3, 4, 5 fields in it. And I'm going to call this table name student info. And I said it has 5 columns in it. Those columns will be student ID, first name, last name, grade, and program code. All right, so it will have 5 columns in it. I called it student info with 5 columns, and I'm clicking create. Now it says, and I know this is ugly, there's other ways you can do it, but this is what I'm going to do. So in here, this first field is going to be student ID. It will be an integer. And now I've got to move over here a little further. I'm making this smaller. I want to find this thing that says AI. That does not stand for artificial intelligence. It stands for auto increment. This means that the first student that I put in there will have an ID of 1. The second student will have an ID of 2, etc. So I'm going to put AI in there. Plus, it's going to be a primary key. And notice as soon as I did AI, it made it primary key for me. All right. So now I'm going to add the other fields. So I've got first name. That will be, again, a varchar. And we said that it was going to be 20 characters. And we're not going to allow nulls in any of these. So I'm going to leave all of them unchecked. Next, we're going to have a last name. It will again be a varchar. It will again be of size 20. After that, we're going to have a grade. That grade will also be a varchar, and that'll be of size 2. I think that's how we set it up. Yep. And then finally, we're going to have a program code. And that's going to be an integer. Okay, that's everything we want in here. There's other stuff we can add, but there really isn't any reason we have to. Now, notice it says here, preview SQL. You don't have to do this, but what I want to show you is if I click that, that's the actual statement that's going to run here. So I'm going to grab this statement and I'm going to copy it to the clipboard, and I'm going to bring it up in here so you can see it. So this is the statement that's actually running when I do this. Create table students dot student info. Then I've got these. I'm going to put each one of these on its own line so you can see what's going on here. So what I did, I think at least, was much simpler than this. You may agree, you may not agree. All right. I just clicked some buttons and did a little bit of typing. Now you'll notice that we've got back ticks here. And that back tick is way up in the upper way up in the upper left-hand corner of your keyboard, right below your escape key. You only need these back ticks if the field has got a blank space in it. I don't have any of those. So if I do want to, I could get rid of all these. So I could come in here and say search, replace, and I could replace every instance of a backtick with nothing. Replace all, and that'll work just fine. What am I doing here? I'm creating a new table under the student's database. It's called student info. It has a student ID in it. That's an integer, cannot be null, and it's auto increment. So it'll start at 1 and just keep going and going and going. All right. Then we've got a first name field, variable length of size 20 that can't be null. Then a last name field, variable length up to 20 cannot be null. Then a grade field, remember that was A, B, B plus, etc. Varchar 2 that can't be null. A program code, we're going to put that into our other table. That's an int that can't be null. Our primary key was set up to be this student ID field, and this is the engine that's being used. And don't worry about what NODB means. It just basically is the standard engine for this. I don't know why I put a blank space there. You can leave it there. It sure wouldn't hurt anything. But that's what's running now. That is basically what's running off of this that I did right here. Now, what I want to show you is right now there's nothing under test. I'm sorry, under students. But as soon as I click save, now notice there's student info. And it's showing me this is the schema. This is known as our database schema. It has the name of each field. It has a little key by the one that's the primary key field. It has the data type of each field, which again, you don't have to worry about that. All right. The fact that none of them use nulls, there are no defaults, and student ID is an auto increment. I could change any of these if I made a mistake. I could drop any of these if I didn't want them. And there's other stuff you can do as well. All right. So that's what I wanted to do. Now, there's nothing in here yet. So I can go to my SQL. This is going to return nothing. And then saying select everything there is from student info. And guess what? It does it. And it shows me nothing because there's nothing in there yet. We're going to fix that in a minute. But I'm going to go back to students. All right. And under students, I'm going to go back to new. I want to put in another table. And this I'm going to call program info. And it's going to have 2 columns in it, simpler than the other one. There it is. All right. And these 2 columns are going to be program ID, which is an integer. And I want it to be an auto increment. So I automatically made it a primary key. And I want it to be program name. That's going to be a varchar. And we said what we said earlier, that the size of that was 50. So that is a varchar of size 50. Again, I can go over to the preview SQL, and that's the SQL that's going to be used to create this table. All right, so again, just because I'm trying to be complete here, there was my first one. Here was the second one, and we will again pretty it up a little bit. So again, I don't need any of these. So I can get rid of all those backticks. All right. So this is saying, again, I've got a program ID, which is an integer, cannot be null, and it's an auto increment. I've also got a program name. It's a varchar, and it can't be null. My primary key is the program ID, and there's my engine. Okay, so that's how I added both those tables. Now, when you come in here and you put in comments here, I believe it's a minus minus. So I'm going to say schema for student info table. And then down here, whoopsie, I'm going to say schema for program info table. All right, as I'm trying to be complete here and show you everything that I'm doing. All right, so let's go back into here. All right, so now I'm ready to actually add some information. And really, now I've got student info. Let me click save. And now I've got a program info in here also. Okay, so I'm going to click on program info here, and I'm actually going to add some data. Now there's different ways that you can do this. If we already had a file with that information in, we could import it in. All right. But what I want to do is just write my own so you can see it. All right. So I'm going to click right there on the SQL, and I'm going to say this: insert into program info. All right. And then I need the name, which is the program name. And then I'm going to say values. I think I'm doing this right. You're going to know real fast. And I'm going to put in here application and website development. That was one. What doesn't it like? It might need to be in parens. I'm going to see if I can put multiple ones in here. The second one, what we had networking, we had plumbing and electrical. Networking and plumbing. All right, I think I can do it like that where I'm putting in multiple ones. If you get errors, you saw maybe the little red stop sign. So we'll see whether or not this worked. All right, so this is the SQL that I put in. So remember, the first ones that we put in here were these. Whoops, where was it? In here. So where I said the schema, this again is the data definition language statements. And same thing here. All right, now I'm doing this one first just because it was less to type, and I'm going to see if this works. So I'm trying to insert, and it's very free floating here as far as how you space stuff. So I'm saying the program name should be this for 1, this should be 2, this should be 3, this should be 4. I think that this will work. All right, right here. I think it will work. We're going to find out immediately. How do I find out immediately? I put it in by finding the button down here that says go. And it gave me an error. Okay, it doesn't like it. Column count doesn't match value at row 1. Okay, well, the reason for that is there's 1 here, but there's 4 here. I thought it let me put it in like that. I should have done a better job of looking at this before class. I didn't. So let's do it the other way. No problem. Okay. I'm going to do this. 1, 2, 3, 4. All right. I'm going to put them in as 4 different statements. You can put semicolons at the end. You don't have to, but you can do it. And what I'm showing you is we're doing this from PHP, my admin. You already have seen this, but it is also possible to do this from a command line. I can show you that. I don't want to right now. There's just too many other things we have to worry about. All right, so I broke this up into 4 different lines. And it doesn't typically like it when you put these all together and boom, copy them all in. So I'm going to copy them in one line at a time. All right, so I'm going to come back up here and get rid of that stuff that was here, paste this in, and try clicking go. Right, again, go. There, one row inserted, so it worked. All right, I can show you or prove that to you, but I want to put the other ones in. Okay, so here's the second one. Sometimes for some reason it slows up a little bit. You have to click go quite a few times to get it to work. I don't know why. It's always been like that though. So there's two of them are now in here. Now I left the semicolon or the apostrophe off of there. That's why it gave me that error. There's three of them. And there's our fourth one. Now, I told you that this worked. How can I prove that it worked? Now I can type in select star from program info and click go. Come on, come on. Why is it slowing down like that? I don't know. There we go. And there's our information. So program ID 1 is application and website development. Program 2 is electrical. Program 3 is networking. Program 4 is plumbing. I now have that in there. So I now have shown you how to go in and actually add that data into the table. So let's put in the next one. All right. So let's see, I had those in here. And this is what I want to have. We'll just put in the first 6 and I'll add the last one manually. Okay. So there's my stuff for the program info. And now I'm going to go and add my stuff. I'll just grab one of these. All right. And this is going to be for the next one. So this is going to be student info. Remember, we don't need this anymore, but we need all of the values. So let me come in here. This was first name, last name, grade, and program code. Like that. All right. That's exactly what we want. And cheat myself a little bit here. Let's see. Thought I put that in there. Did I? No. Let's see. Let me grab these. And I'm going to put them in here. We'll get rid of them in just a minute. But the values are going to be John, Doe, F, and 1. We're going to do this for each one of these students that we have in here. There's a lot better way of doing it that I'm going to show you in a couple days. So we've got 6, 2, 3, 4, 5, 6. Okay. Then we've got Jane Smith, B4. Jane Smith, B4. Then after that, we've got Mark Kent, B3. Then after Mark, Mary Jones, C+3. Then we've got Ken Brown, A2. And finally, we've got Gene White, F1. That's everybody, except for me, that I'll add in a bit. All right. So I'm going to add these in again. There's better ways of doing it than this. This is just the way I'm going to do it for now, because we're just being introduced to this. So now I want to go over to my student info table, SQL. Now I'm going to start putting in these. So there's my first one. The good news is nothing red over here. And I'm not sure why the big delay in here, but there is one. Oh, gravy. Insert into student info, first name, last name, grade, program code, values. That is all correct as far as I can tell. The go button here is not being very helpful. There we go. Okay, so that one was put in. So that's our first record. There's our second record. There is our third record. Here is our fourth record. Our fifth record. And our sixth record. All right, now to verify that worked, I'm going to again come in here. Now I'm going to do a select star from student info. This where one just means show me everything. It's superfluous. You don't need it. All right. And there's our students. Okay, so we now have a database that we created called students, and we added into the students database two tables. One table called program info and one table called student info. Everything that I've done in here other than when I created the database, I've got this. So insert 6 student info records, which is what I did there. And down here was to insert 4 program info records. So that's all been done now. All right. Now let's go back and look at some of the other stuff that we had done in here. All right. So, like I said, you're getting all this stuff. You're getting everything that I'm doing, you're going to get. Okay. So let's see. Let's try running these right here. We already did the first one, but that's okay. We're going to do a select star from students. And it's from student info. All right. And there's all my info. I can also select star from program info. And now I've got that. Okay, so that all worked. Now let's see if we can get just the first name, last name, and grade. All these have got to change from students to from student info. All right, so let's try all these. So that's student info. Okay. So we did this one and it appeared to work just fine. Let's try this one now. See if we just get the first name, the last name, and the grade, because as you saw, we got everything in here from the other one when we did the other one. So when we did select star from student info, we got everything, including the student ID and the program code. But if I run that again, now I'm asking just for the first name, the last name, and the grade. And again, this all is case insensitive. So there's first name, last name, and grade. That all worked. Good. All right, let's continue on then. This will give me just the first name and the last name. Remember, these semicolons on the end are optional. So there's just our first name and last name. All right. And then finally, we've got these. So this will give me the same thing as what I did earlier, first name, last name, and grade, but the grade should go from A to Z, and the last name should also go from A to Z if there's any two people who got the same grade. So let's grab that one. They are in order, and the two B's, again, Kent comes before Smith, and the two F's, Doe comes before White. Everything right now is working. All right. I want to tell you too that, and this is not meant to impress you, believe me. I am totally 100% self-taught on the use of XAMPP and PHP MyAdmin, which we're using here. So there may be better ways of doing a lot of this stuff than what I'm showing you. Sorry if there are, I don't know what to tell you. Now, If Ken's name was actually Kent Brown, I could edit it here. All right. I could make a copy of it. I could delete it from right here. I don't typically work from in here. I like to do everything right from inside of SQL. All right. Okay. Let's go back to where we were. All right, we've got both of these. We've got all this stuff. So let's see if this works. So it won't be D1 anymore. Okay, this will be student info. That's what all of these are. And this one is program info. Let's actually put them each one on its own line. Again, you can do this any way you want as far as how you space this stuff out. All right. And I'm saying it's do this from student info, inner join program info on student info dot program code equal program info dot program code. If this was done correctly, if I have created this query correctly, then what I should get is this. Now I could put another order by on it. I didn't show that before, but I could just still say, just like we did before, order by student info dot last name. We'll do it that way this time. And then grade. Like that. It's a little different. I'm just changing it up a little bit here. All right, let's see if I wrote that correctly. You'll typically know because when I go into here and I put in the query, if I get the little red thing here, something's wrong. It doesn't like something. It's not showing me any error. So let's go. Oh, doesn't like something. Unknown column. Okay, good to know. Because this isn't program, here it's program name. That was the error. Oh, still doesn't like something. Doesn't like program code in on clause. Okay. Honestly, this is good. And I'm not just saying that. All right. If I screw up, I want you to see my screw ups because you probably do the same kind of thing. All right. So I must have called it something different. I thought I called it program code. I must have called it something else. It is program code. So there it is in student info. And it's program ID in here. That's okay. That's all. We just got to fix that one. So student dot program code equals program info dot program ID. And I don't know why I'm making all these capitalized here. They can all be lowercase. It doesn't matter. This is totally 100% case insensitive. Now, just in case this works, I'm going to copy it. Now let's run it. It still doesn't like something. It says student program code is not in there. So let's look. So in our student, says here we got a program code. Oh, I called it program name in here. That was wrong. Let's change the name. Should be able to. So let's see. I don't want this in here anymore. I'm just going to get rid of all that. And I'm going to go back to my student thing here. And there it is. All right. So let's see. I actually want to go back into the schema. So I'm going to click structure here. And there it says program code in student. But that's what I wanted. And the other one, program code int. And this one, program ID and program name. So I don't know what it didn't like. So what we tried to do right there was not this, but to put in this. So let's see. I thought that was correct. Order by student info last name. Well, what I wanted to show you too is if these names are distinct, in other words, there's only a first name in this one here. There's only a last name in this one. There's only a grade in this one. There's only a program name in this one. So we really don't need these prefixes. Or we could say here SI for student info. This could be SI. This could be SI. And this could be PI. And then we'd say from student info, SI, program info, PI, where SI.program code equals PI.program ID, order by SI dot last name, SI dot grade. Now it still didn't like this. We're going to fix it because I don't want to, I want to give you the right stuff here. So it didn't like this, but let's see, it's closer now. It looks a little nicer too. So let's go back down to SQL window. Get rid of this, put in this. And you're also seeing when I'm getting the error, there's no syntax error right now. Syntactically, everything is correct here. How do I know that? There are no errors. There's nothing in red here. So if I left the comma off, okay, I guess it still didn't mind, but if I came in here and did this, it's going to eventually find that because there is nothing called first names. Right, I'm not sure why I wasn't finding it there, but it wasn't. So we've got this. This is the same thing I copied in. And let's see, when I put this in here, oh, it did work. Okay. So this is what it looks like. And we said what it should look like was this. Now, the order is different because previously I did it based on the, I did now on the name. Here was not anything, but notice name. Okay. Let's see if we can do these inserts. So insert into student info. Let's see if we can just put here values. I don't know if it'll take that or not. All right. Usually, considering I'm not putting in the ID, it likes me to list the values out one at a time. But let's see if it takes this. Okay. Column count doesn't match row count at row 1. 1, 2, 3, 4, but technically there's 5 because I'm not putting in I am not putting in the student ID. So we'll put in here, what was it? First name, last name, grade, and program code, I believe was what it was. Like that, just in case it works. Let's copy that. All right, it says it inserted it. Now let's see if it worked. So select star from student info. And let's see if we now have 7 records in there, where the 7th record now is me. And there I am. All right, so that worked. So that was the right one here. So now I want to update student info. Set the grade where the ID is 7. Now, how did I know that was 7? Well, I looked and it wasn't hard, but I can always run a query like this. So let's see, I'm about to try to write a query to change that D plus to a C plus. All right, so update table name, set field name equal to value where condition. If I didn't have this line in there, everyone would now have a grade of a C plus. It's not what I wanted. All right, so let's grab this. Don't know where there's my go button. All right, says it worked. So let's select star from student info and see if I now have a C plus for my grade. And I do. All right, so I've shown you an insert. And I have shown you an update. All right, now I want to show you something that I think is interesting. Okay, I'm going to delete me. All right. Again, if I didn't put a where in there, it would delete everybody. So delete from table name where condition. All right, so let's see. It says you really want to delete it. I guess it does ask. Yes, I do. So it should be gone now. So if I come back in here and I select star from student info, all right, and I run this, you'll notice I'm not there. Now for the interesting thing, okay? Technically, doing it this way, now unless I were to manually go in there, student ID 7 is now gone. So if I come back and I run my query that I showed you before, this one, I'm not going to be 7 anymore. I'm going to be number 8. All right, so go, and if I do my select star, and I run it, you'll notice that now I'm number 8. Now I could manually go in there and force that into a 7. That's never recommended. All right, I'm using a tool. You should use the tool. This is an API. This is an application program interface. It's a tool called PHP My Info, I think, PHP My Admin. And you're supposed to use it in a certain way, and I'm trying to do that. Now let's look at just a couple of other things that I didn't show you yet, but I'm going to show you right now. Okay, I'm going to go back to this query that I ran in here just a minute ago. Okay, and I'm going to copy it, but I'm going to put in somebody else. So let's see. All right, and I'm going to put in here Robert King, and we'll say that Robert got a B plus. Okay, and he's in program, I don't know, 3. Okay, that'll work. Okay, that'll work just fine. But I want to do something with this when we get done. So let's make sure this worked. All right, I'm just attempting to add another record here. It's not exactly what I want to show you, not yet, but we'll fix it in a minute. All right, well, what didn't it like? Ending quote was expected. So it's telling me I was missing something in here. There's Robert, there's King, there's B plus. Oh, no, I put that in there. Wrong key. There we go. Still doesn't like something. Column count doesn't match row count. 1, 2, 3, 4. 1, 2, 3, 4. First name Robert, last name King, grade B plus. Oh, now I lost my comma. Oh, gravy. Not a problem. Comma. Grab that. There, it worked. All right. So now when I select star from student info, all right, and I go run this, it's in there, and there's Robert King. Now, I don't like these names. Other than grade, I don't really like the way any of them looks. So I'm going to change them right now and show you how to do that. So with all the things that we've been doing in here, let me go in and grab this. I want to grab these, put this at the top. All right, so all of this. All right. So character, any keyboard character, and special characters, good. Field, record, table, database, primary key. All right. So I've got all that. I'm just trying to collapse this down into one file to make it easier for you if you want to take a look at it later. So let's see. I now have all this, all this, all this. Okay, so I put in these queries here. Okay, I want this one. So again, these are select queries. And this will be insert, update, and delete queries. Now it's all in one piece of paper or one file, whatever you want to call it. There. So I've got all that stuff. So that's everything that I've done in here. All right. But now what I want to do is I want to come in here in this select statement that we did here, select star. In fact, let's do it this way. I'm going to grab every field. So it's first name, last name, grade, and I think it was program code. All right, but I want to rename all these. So I want to use aliases. All right, so instead of first name, run together like that, let's just call it first. This is case sensitive now because I'm making a title. This is last name. This is grade, so I'll just keep it the way it is. Well, I want it capitalized. Remember, that's a G. That's a P. This I'm just going to say here, code, like that. All right. And then I want to show you something else regarding this in just a second. So, aliasing the field titles. Okay. And that's a minus minus. So let's see if that is right for the comment. So I'm going to try to bring the comment in here too. And I get no errors, so that's good. So notice now it says first, last, grade, and code. So that's how I can come in and I can rename things. Just a little bit nicer. All right, nothing fantastic or anything like that, but that was okay, right? All right. So that's the first database that we've been working with is this students thing. Now, it is 11:13, and I'm going to actually go ahead a little bit and show you some of the stuff I was going to show you tomorrow, which is totally fine. It will work out great. All right, and that is this. I sent you a bunch of files today. Okay, so this right here, all of this is the we're just going to call this is the student database stuff. Right? That's the student database stuff. All right, but I also sent you today a couple of other files that were text files. So let me move this down here. And this is going to be another name in just a second. But I want to show you because what I have in here, not there, is, there it is. Okay, I've created another database. Okay, and this database is going to be called Acme Widget, and it's going to have an employee table that looks like this. It's going to have a states table that looks like this. It's going to have a department table that looks like this. And I've even got data to put into it. All right. So the first thing I'm going to do is I'm going to break this up into two files. All right. I want one with my schema in it and one with my data in it. And let's even break it up more than that. Okay. So I'm going to grab all of this employee stuff. I'm going to copy it to the clipboard, paste it in, and I'm going to call this employee.txt. Okay, so that's my first one right here. Then for the next one, I'm going to call this state.txt. All right, and then for the last one that I had in here, I'm going to call this department.txt. Now you might say, what are you doing? I mean, why did you do all that? I'll show you right now. So I'm going to call this department.txt. So I now have these three files. And again, there's a reason for my madness. You just bear with me a second. So let's go back into here. All right. And I'm going to go to new, and I'm going to make a new database. And I'm going to call it Acme underscore widget. Okay. Acme underscore widget. Click create. There's my new database. All right. At the beginning of each one of these, I'm going to say use Acme underscore widget. I'm going to tell it at the beginning that I want to use that database, just so it's sure that it's going to be using that one. Save that. Save that. Save that. All right, so why did I do all this stuff? Well, I'm going to see if I can grab these files and bring those in without me having to type in any retype or copy or anything. So I'm going to import, and it says, what file do you want to import? I'm going to try to do it one at a time. Okay, so I want to choose the file, and it is on my desktop, and it is employee.txt. There it is. I have no idea if it'll work or not. I'm going to click import. All right, you have an error where it says Acme widget. It doesn't like that. I thought that it would want that. Let's try it again without that line. Don't know if it'll like that or not. So now we're trying it this way. So in here, I'm going to choose import. Again, for my file, again, I'll choose employee.txt, and I'll tell it to import it. Still doesn't like it. You have an error in your syntax. All right. It doesn't like this at line 1. So Hey, I want to fix this because I want to show you even though I'm making it harder than it has to be, this is a better way of doing it. So we're going to create employee here like that. I'm going to get rid of all these. All right. So I'm going to see if that'll work. I did not plan this or try this beforehand, which I think now you can tell. So I want to make sure it's Acme. There we go. Import. Sooner or later, this is going to work. Son of a gun. You have an error. It corresponds to your version. Right near dash dash. I thought that I'd save this. I did not. I had 3 dashes there. I don't know if that would screw it up, but that's what I want to do. And again, we don't, even though it doesn't hurt anything, get rid of these spaces before the commas. Save. Let's try it again. So import, file to import, chosen is employee, import. Now it came in. There's my employee. So I've got that. Now let's bring in the other two, hopefully with no errors now. So we don't need this use line. They should only have 2, and I can get rid of these things at the beginning. There we go. So save that. Let's just do the last one quickly as well. Okay, and save that. All right, now let's come back here. We've already added one file. We added the employee. So now we're going to import again. The file to import is going to next be state. Bring that in. No errors. And there's state. All right, and then finally one more time. Import. And this will be department. So I now have those 3 in here, as you can see. And if I go in here and look, so if I bring up, there's department. If I bring up the structure, there's my schema. It's exactly the way I set it up. Now there are no files or no records in here yet. I'm going to attempt to import those as well. So those 3 worked. Let's do this. I'm going to create a folder here that I call imported into XAMPP. All right, and there is employee.txt. There is department.txt. And there is state.txt. Okay, so those are all in there. All right, so now I'm going to bring these in like this. So don't know why it doesn't like that, but it doesn't. So first name, last name, address, etc. So you can see we've got these. So I'm going to save this. And I'm going to call this employee data.text. All right. Then I'm going to go back to the next one. These are all my states. So these will be state data.text. And then finally, I'll come back to the last one, and these will be my departments. Okay, that one's done. That one's done. And this should be called department data.text. And let's see if we can grab these three and import those as well. It says it's putting it into the department, so let's grab department data and see if it works. It says it did. How do we know? Well, we can run select star from department now. And there's our data. Okay, so let's bring up employee and let's see if we can import into there. So the file to import there will be employee data. There it is. Okay, and again, we can come in here and run it. So select star from employee. So there's our employees. I just, I use some of my family members and I used don't know why, but I saw a commercial for the Flintstones. So got that. And then we've got state. So let's see if we can import into state. And that is state data.text. Doesn't like something. Okay, that's fine. Ending quote was expected. Position 1194. Let's look at what we put in there. Okay, first of all, notice the double quotes worked as well. All right, I'm going to use single quotes most of the time. In fact, I'm going to change all these. Because in some relational database management packages, they'll only take single quotes. They're more accepted generally than double quotes are. So there's that one's fixed. So that was the department. That one worked. This one didn't. We'll fix that in a moment. All right, this was the employee. Right, and that one's done too. Close, save. All right, so the employee data, let's do a file, save as, and I'm going to save that into my imported into XAMPP folder. Close that. States it didn't like, so let's do the department one next. Whoa, that wouldn't work. You can't mix them. So save as. There's that one. Now let's look at the last one. It seemed to say I was missing a double quote someplace, which is bad with all these states. So let's just do this. Let's again do a search and replace. All right, now there, I'm missing it right there. It's at least one. So, looks to me like it now is all correct. We'll find out in just 1 second. So let's go back into here. Again, I'm going to go data, the same one. So the file, all right, my internet connection dropped. I don't know if you're still on or not. It says recording has started, but let me come back in here. Son of a gun. I'm hoping that the other one, because that was 3.5 hours. I'm hoping I didn't lose that. So let me come back into here. Select star. All right. So what I was able to do now in this example, what I'm showing you right now, what I was able to do was to come in and took files that I'd already created. Now I'm giving you those again as well. So this was the state data. And I showed you how you can use the import feature. So typically, if you're going to be a programmer, you're not going to be the person typing in this stuff. Somebody else will have typed it in for you. Okay. So let me put in, let's see, grab those, did those already. Yeah. Copy. All right. We now have that stuff in here. We've got um, a new database called Acme Widget, and it has in it a department table, an employee table, and a state table. So what I'm going to attempt to do between now and noon, hopefully I won't get kicked off anymore, is to go to the other file that was in here and run these queries. So you'll notice I've got I got more than I thought, 36 queries. I don't know if we'll have time to do all of them, but we'll try anyway. All right, and I'm going to change that from 3 dashes to 2. Didn't seem to like that with 3. There we go. So you've got all these. So notice some of them are repeats of what we did before. So show all records from the department table, show all records from the employee table, show all records from the state table. So I'll do those very quickly. And then we'll go back and look at some of the new stuff. So there's everything in the department table. All right. Next is everything that's in the employee table. And that's all in there. And finally, we've got, everything that was in the state table. Love to run all these by noon to make sure they all work. All right, so there's my states. You'll notice too, it only shows 25 per page. But if I go down there and I click this, it shows me the rest of them. So they're all in there. All right. So those are the first 3. Show all department whose name begins with a P. P and the percent sign means P followed by 0 or more characters. So that's anything that starts with P. And you'll notice we get programming and payroll. They're not in alphabetic order. So in the next one, we just ran the same query, but put them in alphabetic order by doing an order by department. Again, the ASC that's in there is not mandatory. We could have left it off. Now they are in order. And next, we were told to put them in descending order, which is what they were in originally. So this is everything. Nope, like P. All right, let's change this one. So show all departments, period. Show results in descending order. So we'll get rid of the like that's on here. So these will be the department names in descending order. It says it returned an empty set. Well, that isn't good. Select star from department where department. Oh, I don't even need a where in there. And order by. So let's grab that one. See if we get this in descending order. There they are, web design, all the way down to accounting. They are in descending order. All righty. All right. Show all departments whose name ends with ing. So notice the percent sign is at the beginning. Show the results in ascending order. These are a lot of crummy queries I wrote, I guess. All right. There they are. Ing, accounting, programming, receiving, shipping in alphabetic order. All right. Next, show all departments whose names end with ing in ascending order by department code. So we ordered them by the code this time. Let's not do the whose name ends with ing. Let's just do all of them. So we won't need a where on here. We'll do it like that. All right, so we asked show results in ascending order by department code. So there's code 1, 2, 3, 4, 5, etc. All right, the next one kind of stinks because I'm removing a state, which I don't know why you would ever want to do that. All right, so I'm not going to run this one. So I'm going to put in here, don't run this. Because why would we want to remove a state? I could add a state and then remove it too. But I'm not going to do that. So I'm just going to skip this one and go down to number 10. Show all states in the table with a V in their name. All right, well, we know Virginia will be one of them, but let's see if there's any other ones. And then we'll go back and look at the query. Nevada, Pennsylvania, Virginia, Vermont, West Virginia. All right, so we hadn't talked about this one before. This is like. That allows you to do what's referred to as pattern matching. What do I mean? Well, I'm saying anything, any character followed by a V, so 0 or more characters followed by a V, followed by 0 or more characters. All right. Now this says here, add correct Virginia to state table, also add Vermont to state table. Is Vermont missing? I don't know. Let's look and see if it was missing. No, it's right there. So we don't need to run that one either. Again, don't run this. All right, 12. Show all states in the states table that end with a vowel. So we're almost putting a little programming in here. So select everything from the state table where the state name is anything ending with A, or anything ending with E, or anything ending with I, or anything ending with O, or anything ending with U. And notice what I get, quite a few of them. It says that we have 31 total states ending with 31 of our 50 states end with a vowel. There's the A's. Oh, I guess it's not done like that. They're in order by state. And there's more on the next page, including Missouri should be in here, right? There you go. So let's run the next one, which says all the ones that don't end with it. So there should be 19 of these. Notice it's not like. Okay. Again, there should be 19 of these. 18, 19 total. Okay. And there's one on the next page, it must be. Or maybe they're all here. I guess they're all here. Okay. All right. Show all states with 2 or more words so that they have a space in between there. West Virginia, New Mexico, New York, etc. So I don't know again how many there are. So we can check that out. There we go. Looks like there's about a dozen or so. 10 total. Okay, you notice they all have spaces in there. The Norths, the News, the Souths, and then Rhode Island and West Virginia. All right. This is the same thing, but it's just in order by, so we ordered it by state name, so I don't even have to run that one. Show all employees that live in St. Louis. Only show their first name, their last name, city, state. Okay. First, let's do this, just so you can see this. So let's select city from employee. All right, I don't even know how many employees there were, but that's okay. So you'll notice what's in here. There should be these 3, 4 in here, it looks like, from St. Louis. So we'll run the query now. And you can see it's where city equals St. Louis. And again, it is case insensitive. Do we get just the 3? Yes, well, 4 of them, I guess. Yes, we do. Okay. 17. Show all the ones who don't live in St. Louis. So notice it's a not equal sign. There's actually other ways of doing it. And I show you another way next. So for the city, you'll notice there's no St. Louis in there when we look. And another way that we can write this is to run that same query, but instead of having a not equal like that, which is pretty much the standard in most languages, we can put it in there as a less than followed by a greater than. And I should get the same results, and I do. All right. Oh, this was just doing it in descending order, so there's no biggie there. Now, these are the more complex ones. All right. Now, notice number 20 is wrong on purpose. Says do a join, show all employees, and it's joining 2 tables. And we should get back 550 records. Why? Because we've got 50 in 50 states and 11 employees. 50 times 11 is 550. So it's going to do every possible combination in here that there is. So you'll notice 550 total returned. It's got everybody that there is, every combination thereof. That's called a Cartesian product join, and it is almost never done. All right. It's usually a mistake. So here's doing the same thing, and I'm showing you two different syntaxes. I'm going to run this query and then the one below it, and then we'll go back and look at each of them. I'm going to run this query, then the one below it, and then we'll go back and look at each of them. All right. So we've got our 11 employees, their first name, last name, their city, and their state. All right. And if I run it again, but I put the next one in there, we should get the exact same results that you just saw. And there they are. Now, what's different between these two queries? Okay. This is the way I learned to do it back in the olden days, like in the 80s. Yeah, 40 years ago. All right. In fact, it was closer to 35, but still 35 years ago. That is one way that you can write this. The other way is the newer syntax, which is what our book showed, that look like this. All right. And then I've got a bunch more. I'll let you run these if you so are so inclined. All right. So a bunch of joins so you can see those. All right. Next, let's go jump up to 27 here. Update my address from 751 Parr Road to 755 Parr Road. All right. So let's do select star from employee. So right now, let's see what it does say. It's got me and it's got 751 North Parr Road. You can see that. Okay, so let's run that query, which is an update query. We'll run it. All right, one row affected, which is what it should be. Let's select star from employee again. See if I now get 755, and I do. So that update worked. All right, then we're altering the table. All right, we're adding a salary. Saying this again, we're altering the table. This is the first time we're putting in, not all we've been doing so far has been DDL, data definition. This is a DML, a data manipulation language query. So as it says, excuse me, we're altering the table to add a new field. So let's alter that. And it says it worked. So now if we do go in and we select star from employee, you'll notice that if we do this, you get a salary and it's null for everybody. So we're going to go in and start filling those salaries in. If you worked in the programming department, or if you worked, oh, I redid this. I don't know why I would do that. Let's just change that to this. No, we'll do that. That's fine. We'll say that if you worked in programming or web design, so if your department code was 4 or 6, we're going to update that salary from null to 8,500. Okay. Oh, I just showed two ways of doing it. You can say where this, or you can use the in. This is considered the better way of doing it. It's less typing and usually it's clearer. These queries 30 and 31 give you the same result. So I'll just run number 31 here. And now if I select star from employees, you'll notice that some of them have a salary now. See that? But only if their department code was a 6 or a 4. Okay. Here's shipping and receiving. I don't know why, but I did them all. I did them as two different ones. I don't know why, because they're the same. They're making the same amount, but that's okay. So here's shipping. All right. And here is receiving. And you'll notice now, I believe, other than accounting, everybody has a salary. So there's null here, here, and here for our accounting people, and everybody else has a salary. So let's fix that for accounting. Well, I guess it's accounting and payroll, sorry. So here is accounting. Here is payroll. Excuse me. Now let's see if everyone has a salary. And you'll notice they all do. All right. Finally, last query. Update the salary. Oh, I guess I didn't for human resources. So maybe there was one missing. So let's look. Was there one missing here? Anybody still have a null? No, I don't have anybody in human resources, it looked like, but that's okay. We'll put that one in as well. Again, these are update queries. And that's it. So I will also grab this and do a save, and I'm going to do a file save as. And this is the one that I did not import this in. So the ones that I imported into XAMPP were the schemas. All right. I'll make another folder here. I'll just call queries. And there's those queries. So that is everything. I'm not going to do that. That is everything that I wanted to get through today, plus some. All right. So tomorrow, what we're going to do. All right. Tomorrow, then, what we're going to do is to continue on with this. And I'm not sure exactly how we're going to do that. I've been working on something and we'll see if I get it done by tomorrow or not. Okay. So that's really all that I had for today. Thanks for listening. Now, what I am going to do this afternoon, I'm going to have lunch. But after I have lunch, what I am going to do is I am going to make a private video where I am going to go in and I'm going to do that you were supposed to do last week. Now, if anybody watching this live or on tape, if you did not turn in a test, you will right now in Inside Rankin have a 0 for your grade. If you turn in something before 8 a.m. tomorrow, you will get partial credit. If you turn in nothing, it'll be a 0 and it's not going to be able to be removed from your grade. So hopefully all of that made sense to everybody. All right, so with that said, Have a good day. I'll see you at 8:05 tomorrow. Bye.